Hey folks, this is me, Vishwas, and I'm the host of this podcast. A lot of times I've realized one thing: we are form factoring the code into different languages. And guess what? It's just getting access in the form of an API. And APIs are not just one thing. It's not just an URL which just comes with a form factor of a code or a business logic. It's getting way more mature in terms of what accessibility was getting defined in terms of APIs. And I think GraphQL is one of the most challenging thing to hack. Like it's not kind of a challenging thing, but if somebody has really configured it very well, and it's very difficult to hack. And somehow there is a book on hacking GraphQL, and Dolev is one of those authors, those book. And not to mention the fact that there is a lot of hacking practices that are still going on. There are still known patterns. Here we are here to demystify how can you as a software engineer, how can you as a DevOps engineer, and how can you as an API security tester, hacker, or the tinkerer can think about GraphQL security right now. And thank you so much, Dalit, for being on my show. It means a lot.
Thank you so much for having me. I appreciate the opportunity to talk about hacking in general and more specifically GraphQL.
GraphQL. So, yes. So APIs are getting form factored into different form factors. Like I don't know what is going to be the next big thing in a API space, but GraphQL has been an impact for a longer time. So there's a different form factor of the code. What makes the difference between the other APIs getting form factored, and what is the difference that GraphQL brings on the table when we are thinking about GraphQL APIs in the production itself?
Yeah, so I guess I'll take a step back because I assume we have audience that may not know what GraphQL is about. So GraphQL is really like a query language for APIs. It's no different than REST from like API interaction standpoint. Like you want to get some data from a server, you make some kind of a query or request, and you get that data back. But the whole like paradigm, the whole design, how that's done, that's very different in GraphQL versus REST APIs. So this API paradigm, this shift or new design came from Facebook, I think around 2012, and it was open sourced in 2015. And Facebook developed a implementation of a GraphQL server called the reference implementation that then other people who wanted to develop GraphQL servers could then take that and basically adopt it or look at it as like a reference implementation to develop other GraphQL servers in other languages. So this is like the gold standard, or like the prime example of how to develop a GraphQL server. So that was released in 2015, and I think from what I remember at least, I started hearing about GraphQL more frequently around the year 2019, I would say. It's probably a little bit, maybe before that, like 2018, 19. And it's been gaining a lot of traction. I would say I hear a lot about that a lot more often. I hear about that from a lot of penetration testers, from security people who will, might be required to develop defenses for GraphQL in their own like companies. So it's definitely gaining popularity. But what's important to know about GraphQL is that it's different than REST in many, many cases, especially from a attacking standpoint, but also from like how you would defend GraphQL from like a defensive standpoint. And there, I can talk forever about like GraphQL, but it comes down to a couple of things. Number one, GraphQL empowers the client to get information based on its needs, as opposed to REST. So for example, in REST APIs, you may make a GET request to some endpoint like V1 users, as an example, and you may get some user data back. Where in GraphQL, you may be composing a query that only reads very specific things from that user table, as an example. So you may compose like a payload that only returns an email address of users, as opposed to all their data like REST API would. So this shift the power to the client, because the client is basically in control of what data is returned from the server, at least by default. And then you have all the other challenges uh, of securing a graph. So you can get data in more than one way if you have like a very complex schema. So for example, you could have like a user table and you could have an account table, and that in some way, shape, or form may lead to the same data type in the backend to a degree. So you now need to worry about securing all the paths to that particular data in the graph. And there's also more than one way to implement authorization in GraphQL. So there's no necessarily like one best practice. And I feel like the industry is still trying to develop the common best practices, how to do certain things in GraphQL. So I think it's just a matter of maturity at this point. So yeah, this is just like in the nutshell. But there are other things that make securing GraphQL a bit more challenging, and we can get to that later in the conversation as well.
Sure, sure. Like there is an impact that GraphQL brought at the scale. Load testing, I think stress testing of applications became more and more fun with GraphQL because GraphQL brought in a different kind of an thinking process when we even thought about thinking of something like serverless aspects like fast services still use some services still use GraphQL kind of an API, and still I feel that there is a much more maturity required in terms of the security because sometimes there is a lot of chance that you can even misconfigure your cloud, not just cloud, you can even still misconfigure your GraphQL APIs as well. So I want to know where does the journey of building a secure GraphQL start, and are we securing it the right way? Because fundamental challenge about GraphQL was always about thinking scale, and it didn't happen for a very long time when the adoption was coming up. But now people are thinking at scale security, and a lot of things are happening. So where does the security of a GraphQL API start, and are we still doing it the right way? That's my question.
Yeah. It's a good question. I think it starts, you first need to ask yourself, do you actually need GraphQL? Does it solve the actual problem that you have, or you're following the trend, right? If I assume that a decision was made to adopt GraphQL for various reasons, maybe justifiable reasons. So you're at a point where like, okay, we want to adopt GraphQL, what's next? And I think the next step is to choose the right implementation for you. Some companies use one language, some companies use multiple like backend languages. So it really depends. But the next thing is you want to choose an implementation that is well supported, mature, and has a really good developer ecosystem so that you're getting a lot of the security benefits out of the box. So for example, there is so many implementations of GraphQL today, like I don't even remember all of them, but for example, in Python, you have like at least three. There is I think it's called Ariadne. There is Graphene. There is Strawberry. There is a bunch of others. So all of these are like Python-based GraphQL server implementations. And then you have Java, and then you have Golang, and then you have JavaScript, and so on and so forth. And pretty much every popular language today has more than one GraphQL server. So it really comes down to choosing something that is mature and well supported, because a lot of those implementations are more niche. So there are some Golang implementations, for example, but there are some that are more popular than others. So you want to choose the ones that are well supported, have been somewhat battle tested. I don't want to necessarily like name things that I feel are more mature than others, but if you do the research, you will find more popular, like more names that you will more frequently see. And some of them offer security features, some of them don't. And this is the benefit that you get when you do, a research into what implementation you should choose, because some of them didn't necessarily take the route where they secured by default. They kind of leave it open and you make the decision how you want that to look like. And some of them are more opinionated and have chosen certain design patterns, so that when you deploy that GraphQL server, you get a secure by default or secure settings turned on by default when you deploy it. So I would highly encourage taking those that have strong opinions on security, because you're going to get a lot of good benefits out of them. So for example, there are most implementations today of GraphQL, for example, enable introspection by default. Introspection is basically a mechanism in GraphQL that allows a client to introspect or see the schema and all the queries and mutations and everything that's available on the GraphQL server by sending a very specific GraphQL query and getting some response back that defines that whole schema. It's similar to getting like a Swagger definition or an API, open API definition of a REST API, very similar. So there are implementations today that have chosen to disable that, but most have kept it enabled. So this is just like one very specific example of a design decision. But some people may not look too deeply into the settings, and they may just deploy that, and they may not even know that that thing is enabled by default. So you want to choose something that secures you by default, even if you didn't really think about that particular area. And GraphQL does require taking additional steps to make sure that it's secure on top of like the settings. For example, you want to make sure that clients cannot ask for too much information from your graph, because that could impact performance, as an example. You want to have the ability to look at what your clients are doing and identify malicious patterns. This is not very easy to do in GraphQL, and the tools are a little bit different as well. And we can get to that conversation area as well. But the bottom line is choose something that gets you to a more secure position with as little work as possible. And anything else on top of it you can develop. But there are certain things that can be a benefit right out of the gate.
Sure, I think you can think as a key question for this one, but I want to know, because there is a lot of times I feel recon is the most important step in hacking. Anything you do, recon is the most important step in hacking. But sometimes I feel every GraphQL problem statement comes with an niche understanding. Like, let's look at the architecture first, and let's see what's happening with respect to the security practices that are being implemented on the GraphQL that is getting deployed. So my question is, if you were to start GraphQL hacking as a student, where you don't know what is GraphQL and you are now entering the GraphQL world in order to hack them and test them, stress test them, where would you start? And where do you want the industry to relearn today? Because sometimes down the line, everybody architects the schema, everybody architects an amazing code base, but at the end of the day, it's still a form factor that is getting deployed. So what do you feel we need to think while hacking, and where would you start when you would have had started GraphQL hacking right now? Like if you were a
Yeah.
beginner.
I feel like I'm in a, I would say I feel like I'm in a good position to answer that. And the primary reason that I say that is because 2 years ago, I joined a company called Wealthsimple. I'm still there, and Wealthsimple is huge like GraphQL fan. We have GraphQL everywhere, and we're heavily invested in it, meaning that we are continuing to develop our GraphQL API, and this is our mecca. This is the thing that we feel strongly about, that this is the right thing for the company. So when I joined the company, I heard about GraphQL before, but never really had a chance to go into it. I didn't really have like a reason to learn it, because I didn't really like, I wasn't really like involved in any GraphQL related activities in my previous company. And then when I joined Wealthsimple, I was like, GraphQL is everywhere. How do I go about learning it? So I started like researching things like, basic Googling, like, okay, how do you learn GraphQL security? Is there any like GraphQL security labs? Are there any like books, things like that? And at the time, we're talking about 2020, a lot of things were missing. So for example, I like to learn by doing. So for example, the thing that I remember like looking for first is books. I couldn't find any GraphQL security books. Damn vulnerable GraphQL application, that didn't exist. And I like to try things and learn by hacking them, doing them, like stand up a lab and experiment with things. So I did find like blog posts, but those were like, I would say, scattered data. So it wasn't like well structured. You would find some information about introspection. You would find some information about maybe like how SQL injection might look like in GraphQL, but those like there wasn't like a particular structure. It was just like information that you kind of need to gather that's scattered on the internet and make sense of it. So I learned as much as I could about it. I started from learning what GraphQL is, the GraphQL fundamentals. There's a really good website by the GraphQL Foundation as well as Apollo GraphQL that teaches you the GraphQL basics. So I started there, just learning what GraphQL is about before I even started thinking about the security aspect. And while I was reading it, I started to think about things from a security standpoint. Like, okay, there are arguments here. You can define arguments in the schema. How does that look like from a security perspective? And the next thing that I actually did was develop the embodiable GraphQL application, which is now, I would say, probably the most popular like hacking lab for GraphQL. And that helped me understand how to implement a GraphQL server. So that really helped. And fast forward, I actually ended up writing a book with No Starch Press and a friend of mine called Nick Alex. We co-authored this book called Black Hat GraphQL. So that was the result of gathering all that pieces of information and experience and learning into something that I didn't have in 2020, which is a security book, like a hacking book. So hopefully whoever starts now has more resources than I did in 2020. So I hope that I managed to change that landscape just a little bit. Um, but I typically go from learning the basics and then kind of slapping the security aspect on top of it. And I'm a huge YouTube fan. I have playlists on YouTube where I try to learn as much as possible from people who are smarter than me to a point where I feel I know I have a really good handle on things. So today, I hope that in the current situation, there are far more security resources on GraphQL than in 2020. So it's good news for whoever wants to start now.
So now, where should companies rethink GraphQL? Like, where should they really start rethink? Because I need this answer because a lot of times, if you think about one API, two API, that's absolutely fine. 10,000 API endpoints in one big company, and everybody, one API goes down, probably there is a chance that every API can be compromised. So, where should we rethink as an organization and when we are dealing GraphQL at scale?
So there are some design patterns around GraphQL, and typically you would see like schema first design or schema first development, when you start by defining how the schema looks like, and then you kind of branch out to developing the actual code that handles resolving all those fields and answering all the queries and things like that. When you start developing your schema, you will notice that you will have to do some security things right from that point. So for example, you may expose certain queries. And if you have a public facing API, then you will have queries and mutations that are likely more sensitive than others. So you have to think about, okay, how do you implement like authorization for some of these things? Which fields or which queries require authentication? And do you need rate limiting for some of those? Do you not need rate limiting for some of those? So when you start thinking about GraphQL security, there's like, I would say, the server settings level, which is like, do we enable introspection? Do we enable like debugging or tracing and things like that, which are typically, I mean, there's pretty straightforward answer to these. Like you typically don't necessarily need to enable debugging in production. You don't want to do that. Maybe in development, you might want to do that. So these, I would say, are very like Boolean answers, where rate limiting could be different answers. Like, do we need more aggressive rate limiting? Do we need rate limiting at all? So I would say I would highly suggest to look at the schema as just like any other code, and think about it from like security review standpoint, like secure code review standpoint, because that's ultimately what defines what your client can do and not do, right? Your schema is what allows you to expose certain things to clients. So from server settings to schema review and schema threat modeling, I would say, to then looking at the code that answers those queries and mutations, or responds to those queries and mutations, which is another, basically just like any other source code review. But your schema is your center of gravity when it comes to what gets exposed and how it gets exposed. So I would highly suggest to concentrate on threat modeling that aspect as well. And really think about where you want GraphQL to be. Do you really need everything to be GraphQL? Maybe you already have APIs that are well tested that you can just utilize. There's a very common design pattern where you have GraphQL fronting a REST API. So you're not really getting rid of your REST API, you just put a GraphQL API in front of it. So you're not really completely losing your security testing and the security journey that you went through when you developed those REST APIs, because they're still functioning as the ones that return that data. Hopefully that addresses the question. It's a very open-ended question, so and there's more than one answer, but this is how I see myself going about securing a GraphQL API today.
Sure. I just want to ask you this one question. Is teaching multiple schema that is very vast and a big practice that's happening in GraphQL world? Is it a curse today? Because a lot of times, DevOps engineers, we come, not just me or any guys, we are a DevOps company that we have. Our project is open source and we have a lot of things coming up, and we still face a lot of issues when we look at every PR today. So just think about the multiple schemas getting stitched in a GraphQL environment, and we are now rethinking what security has to be, and that doesn't make any sense once we are into the stitching process. So is it a curse to stitch multiple schemas, and what's your take on it? Because GraphQL brought in that kind of an flexibility, but is it really going to be an roadblocker for any future implementations that we are talking about?
It's a great question. It's a really good question. Thank you for asking that. Schema stitching, I don't necessarily think it's a curse. It's actually like a power of GraphQL. You're basically growing your schema to be one giant kind of super schema composed of other microservices or more than one microservice. It depends on where you also enforce your security logic. So if you have like a GraphQL gateway that your clients go through, and that's where your entire schema is exposed. If you have good security practices, then I don't think it necessarily matters if you have one or more schemas. If you know exactly how your giant schema looks like and the type of things you expect your schema to enforce, because you need to have CI tools that can take that giant schema and enforce all the security controls that you expect your schema to have, all the different types and all different fields and things like that. So my take on this is the stitching part is not the problem. It's really how your enforcement tools and your CI tools, all the enforcement tools that you have in your CI, how they audit that one stitch schema at the end of the day, and is it comprehensive enough? If you have really good tooling to stitch the schema and look at it from a security perspective, do all the testing, do all the checks to see if you have any circular relationships between different types and things like that, then I would say it's not it's not an anti-pattern. It's actually good if you have all these tools in place. So the world is heading towards the schema stitching and the schema federation world, at least in GraphQL. So that's not going away, and it's actually a benefit of GraphQL. So I think the security teams need to just optimize and make better tooling to deal with larger schemas from an auditing standpoint. So one tool, for example, that does really good schema auditing is a tool called InQL by Doensec. It's a security firm, and it allows you to traverse the schema to see any any possible cycles in your graph. So whether you have a small schema or a large schema, it doesn't matter. You can read the entire thing and traverse it. So and I'll say one more thing. I think I attended one conference in San Diego by Apollo not too long ago, and they talked about something called Supergraph, which it basically allows companies to stitch their schemas together and expose one schema, and behind the scenes it could be more than one company. So the industry is definitely heading towards the Supergraph route. So it's inevitable, and I think we just need to develop better tooling to enforce security in a unified and standardized way, no matter what the size of the schema ends up being.
Sure. I think let's talk about a little bit of an attack vector immutability from GraphQL and how is Recon getting different here? Because there is an Akamai report which just says about the 80% of the traffic is still on an API and we are still doing network recon. I feel somewhere down the line we have to rethink security again and again. And that's state of the internet report from Akamai. So attack vector immunity is what we are just talking about. And also there is a chance that you just configure one GraphQL very bad, it just becomes an attack vector for compromising your security. So how big of a deal when we think of an attack vector immunity in terms of GraphQL that is getting implemented today?
Can you repeat the question just to make sure I understand it correctly?
Okay. So let me just rephrase this question. So there is a lot of things happening with respect to network recon. Like people are still going behind, Nmap, this tool, that tool. Metasploit is having so many modules, but still one misconfigured GraphQL can become an attack vector to compromise your entire infrastructure. So how should we actually think about attack vector immunity in this sort of a scale that we are going behind with the GraphQL? And also, how should we actually think hacking into or else demystifying that entire pitfalls of the GraphQL that we have? Because there is no one step or a one size fit all solution. So, how do you, in your everyday practice, think about attack vector immunity when it comes to GraphQL hackers coming and compromising your infrastructure with one approach or else multiple approaches?
Yeah, great question. So I think to answer this question, and especially in environments where you're operating at large scale, it would be nice if you had like a single IP and the only thing that was exposed on it is a web server that exposes like a single API and everything goes through one place. But you also have to assume that when you're operating in large environments or dynamic environments where infrastructure keeps being stood up, things get exposed and then get removed and things like that. And this is where like the network reconnaissance also comes into play, because if you are a company that has hundreds of public IPs, you want to assume that a mistake is going to happen. So you want to, and this is where like the defense in depth comes to play. Like I don't want to like just say defense in depth, but I'll try to explain like how we would go about this. You need to assume that your GraphQL gateway, as an example, is going to get bypassed, and somebody will be able to query like individual microservices, as an example, or like reach the individual GraphQL APIs. So when you do security testing, you want to test them individually, not just through the single like gateway or the single like stitch schema. And you want to test those individual microservices like independently and separately as well. Because if you end up exposing a path to your GraphQL, to one of your GraphQL backend endpoints by mistake, and maybe it doesn't have any type of security enforcement, guess what? You now expose the GraphQL, an unprotected GraphQL API. Because if you do everything through the gateway and something went wrong, you open up the wrong firewall rule or something like that, and somebody has a path to your data that doesn't go through the gateway, that could lead to a lot of issues as well. So my personal take on this is you want to test them not through like necessarily the gateway, but also like from an internal standpoint. I witnessed a lot of these types of mistakes where a certain server wasn't supposed to be exposed and it ended up getting exposed, and the security didn't look the same. There are certain things that look like, I don't know, something when you look at it from like the gateway perspective, but once you're internally, things look a little bit different. So you want to assume that somebody would be able to bypass your gateway and interact with your backend APIs individually as well. So I would highly suggest you test them both, not just like from an internal standpoint. And think about what would it look like if somebody were to interact with your APIs from within one of your servers. Is it going to be completely different? Is authorization going to be enforced at that point, or is it only done on the gateway? So I don't think network reconnaissance is useless in that sense, because at the end of the day, you want to assume that the company made a mistake as an attacker, and you're going to check all the possibilities and everything that's. You basically want to assume that mistakes were made, and you're going to test all these hypotheses as well. And defenders need to think in the same way. So.
Sure.
Yeah, that's how I would go about that. Just assume that your gateway is not the only way to interact with your APIs.
Sure, that's an offensive security view about GraphQL. Somewhere down the line, you have to literally think, I'm making a mistake somewhere down the line, and you have to rethink that mistake again and again. If you don't rethink that, sorry for that. Your your API gateways works well if you're configured it good. If your hardware has been getting compromised somewhere down the line, it's just a waste of time. So there's a lot of things that I don't know about what might happen to my API stack that we have just architected right now. There is hundreds of endpoints. Everything can be at a stake once we don't know where to configure and how to configure. So now, how to mitigate and resolve the threats, vulnerabilities, as well as face less downtimes with the GraphQL being implemented? And what is it all about when you think in terms of a software engineer's perspective? Because software engineering is all about we have to push the right code, we have to keep the DevOps engineers happy, and the DevOps engineer's role is to keep the software engineers happy that their system or the software that they architected is well up and running. But when it comes to threat, we have to think in both the ways. What is happening in the system? What is happening in the software stack? Is there a CVE that is getting based in the software stack, and we resolve it? There's a lot. So how to mitigate a threat and how to resolve with lower downtimes when we are speaking about the GraphQL infrastructure, because fundamentally it's all about that GraphQL minting money for a CFO, CTO, or a CMO, or whoever it is. But there's a lot of things that happens once we face a 0 day or something. So is there an instance that you have faced in such a way that we didn't resolve it, or else we didn't take this very seriously, and now it's a big problem to us? Anything related to the chaos of facing something going down in a GraphQL, how to mitigate it?
It's a loaded, open-ended question, but I would start by or at least advising on ask yourself, what are your primary worries? What is the thing that you're most worried about? Are you worried about somebody like running a denial of service attack against you? Are you worried about somebody getting data? Possibly both, possibly everything. Like everything matters to you. So it really depends on risk appetite, I would say, but you have to also understand the limitations and the areas of concerns in GraphQL. From what I've seen so far, they typically they come down to two categories. Denial of service and authorization are the probably biggest problems of GraphQL today. The denial of service aspect is because clients can ask for a lot of information. So if you're worried about somebody exhausting your resources by composing like very complex queries, then that's an area of concern and you want to develop some mitigations against that. And then you have the authorization part where people can get data out of you. And like I mentioned before, it's a graph. You can get to the same data from more than one query or more than one path in your graph. So you want to have the ability to test for like all your queries and mutations in an automatic way. So for example, maybe you have different roles in your application and you can say, if a client is using this role, they should not be able to get to this data, no matter what query they're using. Or maybe you have a role that is completely open and it should be able to access everything. So like a super admin role. So you want to have those logics in mind when you develop like unit tests, or you can also develop dynamic tests and test for those hypotheses. On the denial of service part, rate limiting works in a very unique way in GraphQL than it is in REST. And you need to understand the limitations and the current state of the industry when it comes to protecting GraphQL APIs, because maybe you're running like maybe you have like a web application firewall fronting your APIs. You want to make sure that your web application firewall can understand what attacks look like in GraphQL. So, and if that's not the case, then maybe you want to mitigate that perhaps after the firewall, or look at others like potential alternatives to that firewall that you're using, because at the end of the day, it needs to understand GraphQL semantics. It needs to understand what would a malicious query look like in GraphQL, because it's different than REST. There are certain things that are similar, certain things that are different. For example, cross-site scripting in GraphQL will be likely mitigated by all web application firewalls, mitigated at least in the sense that like normal looking cross-site scripting payload will likely get blocked, no matter if it's like a REST API or a GraphQL API. But a complex query from structure standpoint that is designed to exhaust your GraphQL API will likely not get blocked by web application firewalls today, because it just doesn't have any malicious payloads in them. There's nothing particularly malicious about a GraphQL query that is designed to just get a lot of resources. So you want to make sure that the tooling that you have today can mitigate against those types of issues that can surface in GraphQL APIs. In addition to that, I would say that you want to use security tools that can support GraphQL APIs. For example, like I think recently, I don't know if it's recently, but like OSZap, for example, has built-in support for GraphQL. So this is a free tool that you can use to load your schema and then scan for like different types of issues in your GraphQL API. It's not going to cost you anything other than like the operational aspect of it to implement it, but it's free. Everybody can use it. You want to do repetitive tests when you deploy to production to make sure that your introspection maybe is disabled. If you decided that this is the right thing for you, you don't have any like tracing data in your responses and all of these type of checks. You want to do that every time you deploy a new schema version, and maybe redeploy the server completely. So you want to do those types of checks, and I highly recommend using the security resources that are out there, whether it's tools, educational resources to learn more about security, possibly my book as well, to learn about the things that could go wrong in APIs and GraphQL APIs and how to test them from like an offensive standpoint. There are other concerns with GraphQL other than like denial of service and authorization, but these are the primary areas of concern that I personally see more often than others. So, just be ready to put controls in place that can address those two problems. Yeah, and maybe if you don't have a publicly facing API, maybe some of these concerns are likely going to be less of a concern, possibly, depending on how you see risk in your organization. And look for resources from companies like GitHub, Shopify, possibly Adobe as well, who are running GraphQL at scale, to see how they are going about things like rate limiting, how they're going about like implementing authorization in graphs. So you can learn from people who have gone through that journey already.
True. I think that's true. I think case studies make a lot of impact. Like you need not have to just go back and dig down any architecture diagrams or anything. Just that simple documentation that says this is how we are metricing out everything and anything in a form of numbers, and it's really giving us that impact. I think probably that's going to say a lot of story in order to get your right practices onboarded quicker and faster than you just fiddle around experimenting with the things. I think that's the best move that you can do. I think thank you so much. I don't have any other questions. I thought about asking you, I think about where is the I think if I think I covered all. I think I covered it all. Thank you so much, sir. Thank you so much for giving such great insight. Means a lot. And let's meet soon on any of the topics that we want to discuss in form of a hands-on demo, or as a probably something like an hacker style webinar that we can do today together. And thank you so much, sir.
Thank you so much for having me.
Sure.